the opportunity to present the Horizon 2020 project that I'm honored to coordinate. His name is HIGHTS, kind of misspelled on purpose. It means high precision positioning for cooperative ITS application. So, quick figure, it takes partner from Germany, the Netherlands, France, Luxembourg and Sweden. Also Chalmers is a partner. It's 3-year research innovation, relatively good budget, 6 million for the 3-year, and just start 1 year ago. So we are heading to finish in April 2018. We are approaching the hot part of the project right now. And as you can see, there is a big, good at least, mix between academia, research center, SME, and also large industry like Bosch, and we have also BMW as associate partner that work with us writing the proposal. So I'll try to fly a bit, but please stop me, and if at the time we have some question. Why high precision? What is our fundamental goal? So high precision right now, as you probably know, because you are all expert and stakeholder, I guess, in the ITS context, is a fundamental enabler for many use cases and applications like automated driving, vulnerable road user protection, platooning. All of these scenario services, they require very, very precise position on the road. And our goal is to get that, to reach like a selling figure is 25 centimeter precision, and how we want to address that. Not reinventing the wheel, but our main purpose is regrouping state-of-the-art GNSS and very ranging technologies, cooperative communication, advanced and fusion consolidation. So we are starting with an analysis of what's already there in the market, because there are plenty already of good solutions individually taken, and we want to take all together to go to reach this ambitious goal. Following the previous comments, what is today's scenario? Each car, each manufacturer OEM has its own different set of technologies and solution equipped, and could be different video cameras, someone has LiDAR, someone has radar. They can have a combination of both, so we have a big variety of combination. And we need to take all of them in account. We are aiming for universal, let me give corner quote, solution. And someone could say, yes, okay, there is already GNSS, Galileo, and GPS. Why you are not using that? Yeah, they can, even in the future, they are promising with Galileo very good performances. Maybe not right now with commercial devices, because commercial devices have a precision of, in the best case, 1.5 meter, except RTK, okay, but that's another case. And they have some limitation. The measure is they always need satellites. In a scenario where satellites are not available, we are kind of lost. And then there is something else to take into account in today's. We have two kind of way of thinking, big family, you name it. V2X based solution is basically the 802.11p, or this European implementation that is ITS G5, etc. And then there are those that are maybe more oriented to have connected vehicles, so cellular based, exploiting 4G, 5G. Yeah, there's something also about politics ongoing between these two visions. They could be merged in the future, but right now they tend to be quite distinct approach, and we want as well tackle both of them. That's just an example of today's scenario of the BMW car offered by BMW through one of our partners based in Munich. Maybe this cannot be seen here from the Beamer, but it mounts a lot of different sensor, radar, laser, camera, and so on. So that's an example of what we want to achieve. We want to have different sensor and get the information, the fuse information from all of them. Very important concept of our project, the pyramid. So we have GNSS that is available, let's say, to everyone. Even legacy car, old car, maybe you have on the cockpit just a cellular phone. It takes the GNSS. You have TomTom. You already have a kind of position. Onboard sensing, and then that some car can have, and then V2X and cellular. We kind of separated because, especially, not everyone that is relying on onboard sensing that they can offer relative position are open yet to cooperate for many reasons. Probably safety is the biggest one. I don't want to enter in this kind of fight because there will be someone that will argue that it still is safe, V2X is still safe, cellular, but it's a scheme, and that we are addressing in the project. So GNSS for everyone, on board, and then could be complemented eventually with communication. But a car could, let's say, do also automated driving only with onboard sensing plus GNSS, like probably Google Car and other that you have in your own facilities. I'm going a bit into details. What is one of the main concepts that we are developing within HIGHTS is the location referencing ITS subsystem. So basically, in order to get the position, we have this ITS architecture where we are taking different input. This is inside one vehicle. The input from the sensing and communication are going both to the, here you cannot read, but it's the local dynamic map, and also to the Geo-Location Subsystem itself, and eventually also other subsystems not tackled. And then the output of both is going to the application. And you name it, the application that you can have with positioning, accurate position. And then if we go to the big picture, this is just a zoom, close up. We have then also other communication with possibly other vehicle, and with the cloud, with internet, with application provider that they can send application that requires this position. Here I named the input-output subsystem. Those are just a few, like a LiDAR that are using the point cloud to reconstruct the images, the radio location, the cameras, the mobility model is also we consider, for sake of uniformity, a kind of input. Okay, DR reckoning, that's a mistake, of course it's dead reckoning. Yeah, I was kind of in a feeling with with that. GNSS and communication traditional. Those are all the input that we can use to complement and to communicate with our geolocation subsystem. And this is really the core where we use the information collected. We implement our positioning and tracking algorithm, and we do the real fusion according to what we want to do. And it's important because it's not just a dummy fusion, it's a data fusion according to the application that we want to serve, to the context. So we have to implement here also the kind of policy that we want to adopt. That's the tricky part. Different scenario, different application require different way of handling the data and fusing the data, and that's why a geolocation subsystem is a box in the box, quite important for the project. Just an example of the interaction. We have a kind of three-dimensional graphics where here we have the sensing, the communication, and then here is the application, and we it starts with receiving a message for this one vehicle A, this is vehicle I. It gets a message, like a CAN message, that another vehicle is approaching. What is the idea that is going? That we send information, we send the messages to the higher level, and then we process. In the same time, we send a kind of V2V or V2X ranging. So in order to get the information, we bring everything up from the sensing to the communication. In the same time, we get also our own position. Yeah, it's a pity cannot be read that, but the higher the system, the higher level gets my so-called ego positioning, so locate itself in a very accurate way, and locate also the incoming vehicle, and then again with CAN broadcast, it communicates to the other to decide to communicate whatever they need to communicate, like to negotiate the policy to approach to a junction or overtaking or so on. This is a just quick example that means that the procedure is not yet trivial, just sending a signal, but it requires a continuous back and forth, a processing up to this level from communication to onboard sensing, communication, and processing. Even more complicated, I think if I have still 5 minutes, not complicated, but to do this analysis, we had to take in account from the state of the art, from the many documentation that is already out there, the relevant use cases. Because as I said before, for the geolocation subsystem, it's crucial to know what is the application that I need to serve. Different scenario, different use cases have different requirements and different application. So we kind of listed them in order to get the most relevant, and for each of them we have the parameter. I just got the example of vulnerable road user, so when a vehicle is approaching a pedestrian, for example, or a cyclist or a motorcycling, and we have to have an accuracy in the 95%, so of the time of 0.2, 0.5 meter on 2D, bidimensional, and 1 to 2 in vertical on the third axis, kind of availability, so up to the 95% we must get this measurement. We have the integrity, how long and how before the message should be present, and the timestamp for how much millisecond must be valid. Of course, for a pedestrian can be valid maximum 1 second. For motorcycle, 0.1 second, because motorcycle is moving faster, quicker. You see, we have to analyze and implement all this logic in the platform that we are going to demonstrate at the end of the project. So it's not like the results are already there, although you can say, yeah, autonomous driving or accurate positioning is as a matter of fact, a reality. Yeah, for a single vehicle is a reality. When we consider we want to have a general understanding, it's a bit more challenging. I'm jumping to the conclusion. What are the open challenges that we want to still solve within the project? One, we are trying to harmonize, as insisted before, the kind of different approach between relative and absolute localization. We have a kind of screenshot from a company that's our partner, IBEO. They do LiDAR and laser scanner. Cannot be seen, but there are some car and the car overtaking. So it shows basically this picture that only with the laser scanner is enough to get a full understanding of what's going on the road and even enable the driving. But there are cases where that's not enough. If we want to store in a map, we need absolute position. We still need to find a trade-off between these approaches. Cannot be clearly separated. And then something about standardization. It's about spectrum protection. So the cooperative ITS is mainly related, of course, not only to safety application. And when we talk about safety application, we must be sure they will work. We cannot have jamming or error on the spectrum. So something that is going on, it's happening this month. It's a future integration into 5G system, and that allowed me to go back to the challenge of the first slide. But it's not yet clear. There is still a lot of discussion. I'm also with the technical director of HIGHTS, Professor Jérôme Marie. He's really a standardization guy as well, so maybe he can later offer even more insight. And another concerning aspect is that this 5G right now is driven mainly by mobile radio player and not yet car manufacturer or so-called ITS stakeholder. So we have to handle a bit. And this is the other big challenge that we hope by the end of the project will be solved at level of standardization. That's all.
Thank you.
Thanks.